Hello and welcome to Slew's latest live show. This is our broadcast on the Messenger mission as it comes to its rather dramatic end. I'm Eric Edelman broadcasting to you live from Smoky Hollow Studios in Slew HQ in Washington Depot, Connecticut. And boy, do we have a jam-packed show for you here tonight. Absolutely a lot of stuff to be talking about. So we're going to be going over this Messenger mission, what it's been doing, and why it's ending now. What's happening here? Why does it need to crash onto Mercury? What's going on with all that? And to help us with that, we're going to have a lot of experts coming on the show. One of them being our wonderful Slew astronomer, Bob Berman, and also a lot of special guests. One of them being Dr. Duncan Kopp, who has an interesting tie to the legacy of the Mercury missions, which we'll be hearing a little bit about today. And of course, we're going to be having a showing of our interview that we had just yesterday with a NASA instrument scientist related to the Messenger program, Dr. Noam Eisenberg, and that's going to be great. And if that wasn't enough, we're also going to be talking about the top 10 interesting scientific discoveries that have come out of this mission. And this is all going to be accompanied by live images of Mercury from the ground. We have our partner in Arizona that's showing us Mercury in midday, as well as a lot of incredible imagery and video that has come out of the Messenger mission itself. of Mercury. So do stick around with us. This is going to be an amazing show. And of course, do feel free to interact with us on Twitter. We are going to be listening into the hashtag Slew Messenger. A little bit of a long one, but if you have questions for us, we might be able to answer them on air because this is a show for you about this mission, and we'd love to talk about what you're interested in. So thanks again for joining us, and welcome as well to our Slew astronomer, Bob Berman, author of Zoom, The Way Things Move. It's great to have you on here, Bob. Thank you for joining me.
Thank you, Eric. Always a pleasure.
It's really going to be great tonight. There's a lot to talk about, and one thing that I'd like to make note of is that we're expecting this spacecraft to end its journey at 3:30 Eastern, 12:30 Pacific, 1930 UTC. This is the estimated time here, but it's going to be interesting to see if that actually happens through this day. Could you maybe speak a little bit, Bob, towards sort of the uncertainties and sort of the drama that's going to be happening today with the end of this mission?
Oh, there's so much to do with it. I mean, the people are heartbroken. They're excited, but heartbroken. The people who have been involved with this, in some cases, for 15 years, many years in space, 4 years orbiting Mercury. And now, if they had their druthers, it would remain because it's working and it's sending back information with every orbit. Unfortunately, the solar wind, disembodied atom fragments, are creating drag, and they've run out of fuel. It's just plain and simple. And if the orbit were circular, it would be one story, but the orbit is very highly eccentric. I think we have even a video of that to show everybody how close it gets to Mercury and then swings away. Look at this. You see how it gets very close and farthest away? We were discussing this yesterday with one of the messenger scientists. What do you call the closest approach? You know, when an object's closest to Earth, we say it's at perigee. The moon is at perigee, that's monthly near spot. Closest to the sun, it's perihelion. So what's the word for Mercury? Closest spot to Mercury. Well, it turns out it's perihermes. Who would have guessed that? Or periapsis, if you're just talking about any orbit. And that's the spot when it's going to crash. So it's calculated that every time around, it loses another few hundred yards, few hundred meters, gets lower and lower because of this pesky solar wind. And the last orbit around, it just barely cleared the surface. So this next time around, coming up in less than an hour and a half now, it's expected that, look, it's going sideways as much as downward. Sideways, and it's going to smash in at almost 9,000 miles an hour. Seatbelts are not going to help with that. Airbags are not going to help. 9,000 miles an hour will smash into some terrain, and that will be the end. And it'll be on the far side of Mercury. We're not going to see it, but the spacecraft, this is so sad, will not reappear. So that'll be the end of it.
It's going to be there's so much to do here, and yeah, this is actually an image of what the crash site expected for the spacecraft is going to look like here coming up. And you can see like the reds are the regions that are higher up, while the blues are the regions that are lower down. That's what those colors emphasize. This is a false color image, not actually what Mercury looks like. But wouldn't that be amazing if it did? But yeah, so this is where it's expected to crash. And like Bob was mentioning, this is going to be on the other side of the planet than is facing us. So there's no really way that we can see the actual impact, even if we had telescopes strong enough to do that. But what we do have today is some absolutely amazing live images. I didn't even know this was possible before we started investigating this show. But we have images of Mercury from Arizona, USA. Right now, it's just about noon. So this is midday. And so this planet is close to the sun, and yet we're seeing from our feed partner image of Mercury right as it is midday here. Here's it coming in live. And so you see, so this is the planet there. This is planet Mercury at noon from Arizona.
And this is so cool. Of course, this is what we do here at SLU. SLU brings live images, no matter what it is, comet, asteroid, any event at all. Next year, Mercury is going to pass directly in front of the sun, a transit next May 9th, and we'll bring that too, live as it's happening. But yeah, look at that. And I like this because this really conveys the broiling hot nature of Mercury. It's so close to the sun, it orbits less than half the distance around the sun than we do. And so it's never far from the sun. That's one reason why its daytime facing side gets so incredibly hot. And you can sense it. Look at that. The air is shimmering. We're looking into a blue sky here. The image is not presented in blue, but we're looking very close to the sun in order to see it. There it is, Mercury live.
And yeah, I cannot emphasize how incredible it is to be able to see this in the daytime sky. The best times for observing Mercury tend to be around dawn or dusk when it's very close to the horizon, which is also tough in itself. But yeah, actually further on in this broadcast, we're going to talk to amateur astronomers, anybody who's really interested in seeing Mercury. This is a really optimal time, and we're going to get some advice from Bob about that coming up in a later segment on this show. But yeah, there's a lot to talk about, so much, and. Just a question to you, Bob. Is there anything in particular that really strikes your heart in terms of this messenger mission that you're looking forward to discovering today?
Oh, there's so much to talk about because Mercury is a fascinating and unique planet, different from any other. And by coincidence, and this is what the media is pretty much ignoring, right now and through this weekend and right through Monday is the very best time of this year, of 2015, to see it. And you don't have to be an amateur astronomer. Anyone can find Mercury, and we'll tell you how. Easily, it's as bright as the brightest stars, really. So just by chance, Messenger is in the headlines and in the spotlight, and it's going to disintegrate 9,000 miles an hour just when it's most easy to see Mercury from your backyard. So we'll talk about that too. There's so much. This is a very exciting show for me.
Really, I'm in the same boat as you, Bob. And it just speaking to just Messenger's legacy, the spacecraft was launched in 2004, and now it's finally ending its mission. But it only got to Mercury in 2011. It took a very long journey, and just in a short while, coming up in this next segment, we're going to be speaking to Dr. Duncan Kopp, who's going to speak a little bit about the legacy of missions to Mercury, and that's going to be a really fun show, a really fun segment. But right before that, we're going to take a really short break, but we'll be right back in 30 seconds with more of Messenger, more of Mercury, more of this legacy, and more of the impending end. So stick around. We'll be right back. Hi, welcome back to the SLU live broadcast of the Messenger Mission's End. As it ends its time visiting Mercury. So right now we're going to have a great segment with a film director and documentarian, Duncan Kopp, who, as well as having a PhD in astronomy, has done a lot in terms of astronomy media. One of them, a great documentary being In the Shadow of the Moon on the Apollo mission and the Apollo astronauts. And it's going to be really great to talk to him today. I believe he's just come in with us. Hello, Duncan. Are you there with us?
Hi, yes, I'm here. Yes, live from London.
Oh, it's so great to hear from you again. It's always great to have you on the shows and your wealth of information. So thank you so much, Duncan. And I wanted to ask you first. You have a bit of a unique tie to the Mercury legacy, don't you? That you have a specific sort of interesting tie. Could you speak a little bit towards that?
Yeah, certainly. It's a bit of a loose affiliation, but my supervisor, John Guest, Professor John Guest at University College London, was one of the mission scientists on the very first mission to Mercury, which was Mariner 10 back in '74 and 1975. And I always used to like hearing stories that he would recount of those very first spacecraft that they sent to Mercury. And what was always quite amusing is he always used to say, you know, it's a story that's only half told. And of course, the reason is the Mariner 10 was a spacecraft that flew past Mercury. It didn't go into orbit. So they only managed to image about 45% of the planet. So the other 55%, they had no idea what was going on. So it really was a pioneering flight back in those days. And really, just that 45% of the planet was glimpsed.
Wow. And yeah, it speaks towards just how far we've come with this messenger mission that has been in orbit for so long, for about 4 years now. And so how do you think we've grown from then to now? Like I have a great example image I can bring up here of just this is something
oh, wow,
that,
yeah,
that
lovely. Yeah, no,
taken.
well, I mean, first of all, you know, we filled in the other half of Mercury that we didn't see before. And but yeah, I think Messenger's a fantastic spacecraft. I mean, look, it took something like 7 years to get there because it used lots of gravity assist to put it into orbit. And it's going into a really hostile environment. You've got to remember just how hot it is out there. And also how cold as well, because you get that dichotomy between very, very hot because you're so close to the sun, but then when you're in the shadow, it becomes very, very cold. And that's why Mercury has these extremes of temperature. It's something like minus 290 degrees Fahrenheit, something like that. And then up to 800 degrees Fahrenheit in the sunshine. And I think in terms of what Messenger's pointed out, I think one of the most interesting things, again, regarding that temperature fluctuation is this idea that Mercury actually has water ice at the poles. And the reason that that ice can exist is because it's covered in a layer of rock. And if it's covered, it's insulated. It's a bit like putting ice into a thermos flask and insulating it. You'll find that it won't melt for a very long time. The same thing happens with the ice at the poles of Mercury. The water we think was brought to the planet by icy comets bombarding that planet in the early stages of the formation of the solar system when Mercury was forming. And then some of that water ice vapor managed to find its way up to the top of the poles where the sunlight actually doesn't shine so much and then became buried in the soils of Mercury and of course is embedded in there today. And that was a really significant finding, I think, for Messenger, because obviously you're talking about the closest planet to the sun and it's pretty hot there.
It's so amazing that that's just extreme temperature variation and what variety can exist on the planet. It brings to mind for me that there must be so much to delve into with this really incredible planet. And my question to you there is, with this mission ending, what do you think is left to do? What is more to discover here? Do you think we should be sending another Messenger 2, Messenger 3, Messenger 4 to Mercury? Is there more to be uncovered here?
Look, there's a classic thing you have to remember about planetary science. Is every time you have a mission, you answer questions, but it always throws up more. So it doesn't matter what planet you visit, you will always have a thirst for more knowledge, because in some respects, this is the golden age of astronomy. These are the first sort of missions that we're sending out to these planets, especially with something like Mercury. The very first time we've orbited Mercury, we've sent a spacecraft that's orbited Mercury. So I think the salient thing to remember is, yeah, there's loads more questions that can be answered. And in fact, I know the Europeans, they plan to send a spacecraft, I think it's something like 2024, in the 2020s, something like that, which will follow up the work that Messenger has done. But here's an example. There's something really peculiar about Mercury in that it's shrinking, and that's because it's cooling. And when things cool, they tend to shrink. And this is exactly what's happened with Mercury. And I think we'd like to know a little bit more about that and understand that process and understand exactly how much it shrunk by, because that can start to tell us quite a lot about the interior of the planet. But we know this has happened because if you look at the surface, and again, this is something that Messenger's really helped us achieve, is there are these amazing scarps on the surface, these sheer cliffs. Some of them are sort of 2 miles high. You know, that's the height of Mount St. Helens. These things would be fantastic if you could go there and walk on the surface. So although Mercury may look a bit barren, maybe a little bit boring, I don't think it is at all. I think it's got this fantastic surface. And I guess spacecraft like Messenger are starting to reveal its secrets, which is always exciting if you're a planetary geologist. Well, it's exciting for all of us. I mean, let's face it.
Absolutely, and yeah, there's so much that Messenger has discovered. It's so amazing to hear about it. And just to delve a little bit deeper into it, I wanted to hand you off right now to sleuth astronomer Bob Berman, who will have another 5-minute discussion here, getting into a little bit more of your knowledge of this Messenger mission. So yes, take it away, Bob.
Well, hi there, Duncan, my old friend. How are you doing?
Hello, Bob. It's great to talk to you again. How are you?
I'm good, thanks. And it's always exciting. And of course, I'll never forget that your specialty, if I remember right, you have a doctorate in astronomy. You sort of hide that fact a little bit sometimes, but we force it out of you. But your specialty was kind of Venus, wasn't it? And so I wanted to ask you, if I remember right, now I could be forgetting one mission, but now we've orbited, you've just pointed out that we've orbited Mercury for the first time, but prior to this, it was the Mariner 10, 40 years ago, that gave us our previous images of Mercury. And if I remember right, now here's what I want you to address, if you would, that was going to be a Venus mission, and somebody at NASA suddenly realized that, wait a second, wait, we can also send that on to Mercury. If we just time the orbit right, it can make a couple of passes past Mercury as well. Isn't that what happened back then? And without that, we would never
have
had
that's
close-ups.
correct. And what you've got to remember is, going back then, we were just starting to look. I mean, this is before my time, so I'm speaking slightly out of turn, but as I understand it, the scientists at JPL were just starting to learn about celestial mechanics in terms of being able to send spacecraft around the solar system by robbing planets of some of their gravity, some of their energy, and flinging the spacecraft onto the next planet. And this technique is called gravity assist. And it's really how we've managed to send spacecraft such as Voyager 1 and 2, and before that Pioneer 10 and 11, way out there into the outer solar system to explore Uranus, Neptune, Jupiter and Saturn. But of course you can play the same trick, get into the inner solar system, and that's exactly what they did with the Mariner 10 spacecraft. Is they flew it past Venus and then on to Mercury. So they sort of killed two birds with one stone, I guess. So it became a far richer mission from that point of view, because these planets were pretty much unknown about back in the 70s.
Yes, and Mercury was a poor, neglected planet, and now now with Pluto's demotion, it is the smallest planet, as you know, and always fascinating. Here's the darkest planet in the known universe, and the one with the greatest temperature change from day to night, and yet we had no intimate knowledge of the surface. We assumed it was cratered, but it took until Mariner 10, and then 40 years passes that until we finally send something to have a closer look, to orbit around it. So this Messenger has been very exciting. We're going to talk in detail a little bit about its discoveries, but I know you've been following this as well, Duncan, and what to you has been the most exciting discovery, and have there been any surprises for you?
Well, I think, as I was saying to Eric, I think the most exciting and surprising in some respects discovery is this idea of ice at the poles. And of course, you've got this planet that's so hot and then also so cold, but it's been able to sustain that ice. And I just think, wouldn't it be amazing if perhaps there's a later mission that perhaps could sample some of that ice, get to the polar regions, because what a story that would tell, because that ice is water that's left over from the formation of the solar system. So that would be very interesting and surprising as well. It was quite surprising, quite an early on discovery. So that was interesting. And again, I think what these missions always do is they paint a different character with regards to these planets. We think we know them from point of view of a planetary geology perspective, but every time you have an opportunity to study these planets in detail with a craft as amazing as Messenger, all manner of new thoughts and theories tumble out of those images. And you can't help wondering, the scientists now who are going to have years, the mission may end today, but there's years and years of research with all those gigabytes of data that's been collected from Mercury sent back, and we'll be poring over those images for many years to come.
Quite right, quite right. Hey, thank you so much for joining us. I'm going to send it back to Eric. Before I do, will you join us a year from now, next May, when Mercury transits in front of the face of the sun? We're going to be covering that, of course, here at SLU. And will you be part of that with us, Duncan?
Oh, you bet, Bob. Yeah, no, yes, please. Thank you for having me. I'd love to. It'll be an exciting event.
Good, good, good. Eric, back to you.
Oh, thank you, Bob, and thank you again so much, Duncan, for joining us. This was a really great segment, and we look forward to seeing you again a year from now, and probably a little bit more in between then as well. But yeah, thank you for recruiting for us here, Bob. It's good to get a jump on those things. We here at SLU, we don't stop for one moment. We're getting you there years in advance. But yeah, thank you again, Duncan.
Always great to talk to you, and happy SLUing, everyone.
Yes. Thank you.
And now we're going to be going on to a very interesting segment just coming up where we're going to be talking a little bit about the interesting things that Messenger has been doing during its long stay over Mercury, sort of the top 10 scientific discoveries. And those are coming to us from an April 16th press conference that happened with NASA that just a little while ago, where we're talking about some of the most interesting things from their mind that happened with this spacecraft. And so we'll go into a little bit more detail about that. And we're also going to be very close to hitting the time when Messenger is expecting to hit Mercury. And so we'll be going into a little bit more detail about that and what we can expect and what we can learn right after this quick break. We'll see you again in 30 seconds. Stay tuned. Hi, everyone, and welcome back to SLU's live broadcast on the Messenger mission as it's right about to impact Mercury. So what we're showing you here right now is the live impact site where Mercury is expected to go down. This is it. Again, it's false color. We don't have Easter egg Mercury going on. This is just to show you the blues are the lows, the reds are the high in terms of how high or low different things are. And also, this is another great image that just came in yesterday from the Messenger spacecraft, showing you how up close this spacecraft is getting to Mercury. It's getting closer and closer, and today is the day that it's expected to make its impact. That impact being just 6 minutes away now. And I also want to emphasize that, of course, we will not be able to see it in our live imagery because where Mercury will be impacted is on the side that is not facing us, it's facing the sun. So even if we had like super-duper incredible telescopes that could see with that sort of resolution, we wouldn't be able to see the right side of Mercury. So what we can do is we're going to celebrate the time that Mercury is expected to impact, and we're also going to make sure to give you confirmation when that happens. So confirmation, because it's on the opposite side of Mercury that we can see, it will not happen until we don't see the spacecraft come back around the other side of Mercury. And so what we have is we have our social media team on the case. We're on Twitter, we're on Facebook, we're on Google+, we're on Tumblr. Wherever you are, we're there too. And so we're going to update and make sure that you guys have the latest news if we get information after the show about the status of the spacecraft. And so stay tuned on there, and we'll be sure to keep you in the loop with all of that information. But as it stands, as we're making this countdown, let's make it another countdown as well. Let's talk about those top 10 incredible discoveries that Mercury has, that Messenger has made of Mercury so far. And so starting with 10, going all the way to 1, we can have a fun segment of it, Bob. And so starting with number 10. Which I think it's number 10 for a reason. We have field-aligned currents that has to do with electricity, magnetism in the planet, and it's aligned there. But going on to number 9, there are high-energy particles, these electrons, that are caught in this magnetosphere of the planet. But skipping that a little bit, we have the dynamic magnetosphere that's happening as well. It's electricity and magnetism. We don't need to go too deep into that with this sort of broadcast.
And let's mention, of course, that its magnetic field, its magnetosphere, is only 100th that of Earth. It's a wimpy magnetic field. It's not like our nice, powerful one here.
That's a
so
good
what
point.
we're talking about is nothing like Jupiter's or even Earth's magnetic field. Yeah.
And you can think of like so these discoveries are about the magnetism around the planet. You can think of the magnetism like something that's protecting it from some of these particles that are rushing from the sun. And so since Mercury's field is so much less powerful than Earth's, you can think of it like somebody who's really close to the center of a blast zone and who has a paper bag versus somebody that's like a mile away from the blast zone with like an iron bunker. Like the Earth is much more protected from the stuff than Mercury is. So there's extreme stuff that's happening. And one of those, the eighth coolest discovery being the dynamic magnetosphere, the fact that it's so close to the solar wind that there's waves that happen in the magnetosphere because of the interaction with the solar wind, which is really interesting. But getting on to discovery number 7, which I think is pretty cool, that Mercury has some interesting seasons. It has what's called a seasonal exosphere. And so that means it has different colors or different intensities of colors associated with different seasons on Mercury. But I didn't really think Mercury had seasons in the same way that Earth did. Isn't there a bit of a difference there, Bob?
Oh, very much of a difference. Normally when we talk about seasons, every other planet's seasons is due to its tilt, the tilt of its axis. But Mercury is the only planet in the known universe that does not have any tilt at all, not even a half a degree, not even a tenth of a degree. It travels around the sun perfectly straight up and down, and so therefore it does not have seasons. So when we speak of changing conditions, we're speaking about a different feature that also makes it unique, and that is its very eccentric orbit. It comes much closer to the sun at some points than it does at other points. It speeds up and slows down more than any other planet, and it's the changing distance that gives us our seasons. Let's point out also that in this next minute, this is when we're expecting the impact. And because we saw that color-coded map showing the terrain on Mercury right around the spot where the messenger spacecraft comes to its closest point, it's more likely to hit higher terrain, of course. There's a several-mile difference between the highest points and the lowest points on that image. So I would imagine the spacecraft's traveling almost sideways at this point. Remember, it's going around Mercury, and this is the lowest point of the orbit. So it's not crashing in, heading straight down, but it's just slightly looping down. And so it's likely to impact onto a hill or a mountain or a cliff than lower terrain. It only loses a few hundred meters every orbit. So I wonder if there's any chance at all that it'll skim through some valleys and just manage not to hit the ground and then reappear to cheers and applause, when it emerges from the far side instead of vanishing. A little bit of uncertainty there would be very exciting.
And this is it, Bob. This is 3:30 Eastern, 12:30 Pacific. This is when Messenger has been expected to impact Mercury if it's doing it on this orbit, which we think it will. And so, but we have to, what we'll see is if it comes out on the other side of Mercury at the end of all this. But if it doesn't show up, that's when we know that the Messenger mission has ended in terms of the spacecraft portion, that spacecraft has made its own crater on this cratered surface that is Mercury. And so, congratulations, everybody.
While we're speaking, this is when it's happening. I don't know why we're smiling about a beautiful spacecraft smashing itself to smithereens at 9,000 miles per hour. That's beyond the help of any airbags or anything. Somewhere in this region that we're looking at, more likely one of the red parts, which is higher up than the blue parts, which is low down. But I guess it's exciting. Also, we're boys, and boys like explosions and things like that. So. But we can tell you, having spoken to people involved in the mission, they're not at all happy that it's ending, because it's been a magnificent spacecraft. Some of them have devoted a big chunk of their professional lives to this, and this is the minute. in which it comes to a close. Of course, they still have analysis of data to do, and that'll keep them busy for probably the next year.
But yeah, this is the experience, and it's I mean you bring up a good point in that the solar system is pulling a bit of a Michael Bay today, and we're having some explosions, but it's in this drama, in this ending, it speaks a bit to the cycle of life that we're seeing with the spacecraft that we're having. And so, yes, again, we're going to have a interview. We had an interview yesterday that we're going to be showing a little bit later in this broadcast with Dr. Noam Eisenberg, who's a part of this mission, who's going to tell you a bit about that sentiment. But one thing that he was mentioning to us sort of after the interview is that it'll be fascinating to see. There's going to be future missions that are going to be coming up, which I believe one is Bepi Colombo, I think it's called, by the ESA, and they're going to be sending a mission there in about a decade, and we'll see if that spacecraft can see the debris or the crater made by this spacecraft. And so the spacecraft itself, right here, Messenger, making an impact on the observations of a future spacecraft in that circle of science life, so to speak.
Very poetic. I like that.
Oh, thank you, and thank you for our viewers for joining us here and celebrating the end of the Messenger mission, celebrating and mourning, and really just putting our eyes on the sky and putting our eyes on the accomplishments of Messenger. Because for what better way to celebrate the end of a mission than to remember its accomplishments and what it has done so far? And sort of in that spirit, we have more information about the top scientific discoveries that Messenger has made. We just did number 7 on the seasonal exosphere before the time of the Messenger mission ended, and now we're on to number 6, which is something called global contraction, which actually Duncan spoke to us a little bit about earlier on in the broadcast, and we actually have an interesting video that speaks toward what this is. That's sort of that shrinking of Mercury in certain ways, and I believe it's shrunk up to about 7 kilometers in radius in certain places. It's really fascinating.
That's about 4 miles. I mean, the planet's getting smaller and smaller. You know, we better keep watching it while we can. You know,
that'll just absolutely disappear from us. And so, yeah, this is again one of those false color images that shows you the height of Mercury at different points. The red being the higher points, the blue being the lower points. And so we see the blue region as an example of this this global contraction that's occurring. That there's places that are squeezing in a bit, and so that we have numbers. Go ahead.
Go ahead.
Oh.
I was going to say that because the planet is so dense, it's the densest of all the planets. It's 5.5 times the density of water, even denser than Earth, which is number 2 in the density department. So you don't think of something that's so compact already as having a proclivity for shrinking down further. You know, you'd think more like Saturn, which is a little fluffier than cotton candy. It's less dense than water is. So, but nonetheless, that's why it's one of the surprises. I'm sorry, you were about to get to number 5, which is a nice one.
Oh yeah, but you know, we can talk about these for as long as we want. This is fun stuff, and so. Yeah, we have lots of interesting things here, and number 5 being volcanic deposits. So, I mean, when I think of volcanoes, I don't necessarily think of Mercury, but apparently Messenger has been learning a bit about volcanoes in terms of this nearest planet to our sun.
Yes, absolutely. As we look at an image just taken yesterday on a very recent past, so it's still doing stuff. Messenger, or was still doing things. I guess we're going to have to, at this point on, we're going to have to put it in the past tense, sending images as recently as yesterday, maps of the surface. Look at this. This is color-coded. Be nice if the planet had that kind of color. In reality, Mercury is a kind of dark orange color, not too dissimilar from Mars, except it's the darkest planet in the known universe. It's the least reflective. So that's strange. So these colors are nothing like what's really there. They're just maps to show you where the deepest depressions are in blue and the highest up terrain, which is in red.
And the terrain, looking at this terrain, is so important when looking at the history of volcanism, because volcanism is, and in some ways has carved the history of the surface, that there are certain features that wouldn't be here without that volcanic activity. And so Messenger has been learning all about this, and about the shapes, the sizes, what has caused Mercury to look the way it is, and just very detailed maps, again, false color, of Mercury's surface. So this is all just incredible discoveries that have taken place over the past few years as Messenger has been orbiting this planet. And then number 4, I find very interesting. It's to talk about a certain phenomenon called hollows, and they look a little eerie with their namesake there. So here they are coming up, and we can sort of describe it as we see it in the video. It's just coming up in just a moment. There it is. So the hollows being sort of you see those little like sort of wing-shaped objects that are sort of carved out of that surface feature. Like there's the hollows being hollowed out places where certain surface material has been removed, and it created these sort of eerie, interesting shapes. And that's something that Messenger has viewed over this past few years. Very fascinating stuff.
This is really weird. The whole mesa, which is coming up toward us in 3D, looks just a little bit like a pig's nose, with the nostrils there being the hollows.
Oh, that's very true.
That?
That's fascinating. And yeah. Let us know on Twitter using the hashtag #SlewMessenger. What do you think it looks like? Let's have a Rorschach test with this image. Let's do it. And so we have the hollows, and then also we get back into, there's a lot of stuff about the magnetic field, of course. And so number 3 is that it's slightly offset from how the planet is rotating. And so that's discovery number 3. And also then we have discovery number 2, which is something that we talked about quite a bit earlier, but which is just so fascinating. There's a reason we were talking about it for quite a bit. And that is the ice caps on Mercury. We always hear about, Mars and try and find the polar ice caps. But this is ice that's found on Mercury. And that's just so fascinating. You don't think about it like that. But, Duncan spoke towards the temperature gradient and how that ice can hide. It's just so cool. It doesn't actually look yellow. It's just to point out that that's where the ice deposits are.
Now, in all fairness, we've strongly suspected, to the point of almost being certain, for decades about ice on Mercury. So what Messenger has really done is confirmed it, nailed it. But we've seen from radar, which has been bounced off Mercury for decades now, and even from some preliminary analysis of the Messenger mission, we've been suspecting ice on the polar. There seems to be a thing that happens on a celestial body that's straight up and down. Because Mercury has no tilt, it means that sunlight can't penetrate any depressions or craters at the top and at the bottom, in other words, at the poles. So we see this on Mercury, we see this on the Moon. The Moon also has very little tilt relative to the incoming sunlight. So apparently any place that doesn't get direct sunlight can harbor ice, and that's what we're seeing there. A little paradoxical considering it's so close to the sun, but here it is.
It's so cool, and it speaks towards a little bit of the history of the planet and what it experiences. Like there was, a question of where it could get this material, and that also speaks toward the fact that we're seeing from Messenger that there's a possibility of a meteor shower on this planet, which was not something that we always thought was possible. It's so fascinating that other worlds can experience those streaks of light like we're seeing very recently with the Lyrids, and we're going to see with the Edo-Aquarids. Great stuff, really. But as we count down here, we have one last number, number 1, which is really, it's so interesting in terms of the formation history of this planet and what it means to be Mercury, and all of how Mercury has come to be. And so number 1 on the scientific discovery list that came out of NASA was the fact that it had a very high percentage of what are called volatiles. These are elements that can't really withstand very high temperatures. And so to see a high amount of these objects means that we can nix certain formation scenarios for Mercury that had to have it be at really high temperatures. And so this speaks toward Mercury's past and where it's been.
Absolutely, the ratio of potassium to thorium, the fact that there is as much chlorine and sodium and sulfur as there is, all of this shows us that it could not have been a molten object that then settled down and then acquired its craters over billions of years through impacts. It probably formed through the accretion of planetesimals, smaller bodies in the solar system that never went through an intense heating. Although looking at our live images now, here's our SLU partner who's bringing us real-time images of Mercury in the daytime sky, close to the sun, in the broiling midday, and you can see these live images that's shimmering all over the place, but you can nonetheless make out a phase. You can see it's a little bit fatter than um, a half Mercury, and that's good because that's what we see when Mercury is at its brightest. We see this shape, this phase.
Yeah, I'm so blown away by how amazing it is that we can see this in midday, and we're going to talk a little bit about watching Mercury coming up. So that we had a very fun segment on what Messenger has done. We've heard a lot from Duncan Kopp and just looking at this list of incredible discoveries, and we have more too to talk about. Even though we have passed the official time when Messenger is supposed to impact the planet, we still have more to talk about. Coming up after this segment, we have very interesting things that Messenger has done, including one thing with our moon, and also talking a bit about how we can observe it. And of course, coming up, we can't forget that there's going to be a play of our interview that we did with Dr. Noam Eisenberg, who's going to give us a bit more insight into the intricacies of this mission and nerd out about it for a bit, which is quite a lot of fun. He was just so enthusiastic about what he does, which is really great when you get a scientist on like that. And so we're going to be right back with some more interesting stuff about Messenger and Mercury and everything in between. So stick around. We'll be right back in 30 seconds. Hi, everyone, and welcome back to SLU's live coverage of the end of the Messenger mission, as it has most likely impacted Mercury. That happened about 15 minutes prior, 14 minutes, and we're continuing on with our celebration of this mission, what it's meant to scientists, and what it has done for us in terms of our understanding of Mercury, and also in terms of its fascinatingly unique perspectives that it provides us, particularly one I'm thinking of Earth's moon. Would you be interested in introducing that clip, Bob? It's so cool.
Yes, of course, there's so many similarities. Here's a object with essentially no atmosphere, no protection from impacts. When you were speaking earlier about how the Mercury has very little magnetosphere, also has no atmosphere to protect it. So there's interesting similarities. Yeah, let's run that. Let's take a look.
Yeah, this is a time that was very, very popular on the world for astronomy, and we're going to see it from a very different perspective. So here's the clip. It's paused at the beginning before I play it, just to let you know.
So cool.
The circle on the left is Earth. The circle on the right is the moon. And what we are going to see is the lunar eclipse that's taken place at this time, as seen from Messenger at Mercury. Like, just keep your eye on the right dot. See what happens to it as it falls into Earth's shadow.
You're going to see a time lapse of the moon going into Earth's shadow. Of course, you can't see Earth's shadow, but look at that. The moon has disappeared into Earth's shadow as seen from the planet Mercury. Now, when we were reviewing this earlier, we were saying, hey, wait a minute, did they Photoshop this a little bit? Because the moon is actually 30 Earth widths away. You can see Earth on the left, the moon on the right, and the moon does not appear 30 Earth widths away. So did they do some trickery with this? And the answer is no, because if you picture yourself at Mercury, you're so close to the sun that when you see Earth, you're looking outward, not sideways from it. So the moon is actually beyond the Earth, quite a bit beyond. So although the moon appears to the right of Earth, and it is to the right, it's also way past the Earth. So as it disappears into our shadow, now suddenly the apparent separation between the moon and the Earth makes sense. The moon appears to be only perhaps 10 Earth diameters from it in this, and that's because the separation is mostly along the axis that we're facing. It's off in the distance, and there it disappears into Earth's shadow. Something we've never seen before, an eclipse of the moon as seen from
It's
another planet.
It's so absolutely mesmerizing, and we have just a lot of great material from Messenger. And here's another fantastic video where it shows you a sort of a ride along of the surface as Messenger's going along. This is just a compilation of multiple images that makes it look like we're riding along with Messenger, and it's just
As we
absolutely.
approach the Terminator, it should be said, look how the shading gets more intense as we go along. The craters look darker. The little hills are more and more in relief because during this whole clip, Messenger was going around Mercury, so we're not just looking down at a flat surface. Watch how brighter it is now, less bright now. We're seeing more relief, more of the details, more of the holes and the grooves and the shading, the cliffs casting their shadows, until we get to a point very near the day-night line, the Terminator, where now the craters that we see are in full darkness, and their walls are casting shadows that almost fill the entire crater. So fantastic images, videos as we go around the bend and circle Mercury.
Absolutely gorgeous stuff, yeah. And just Messenger has done so much, and I just love to show this one image here that celebrates. It says 1,000 in this whole mosaic, and it's celebrating 1,000 images that have been distributed from this mission that a while back. And so there's just an ample amount of resources that not only the scientific community, the public can get to really enjoy what Messenger has accomplished. Absolutely incredible. And sort of speaking towards the public and what anybody can do in terms of relation to this planet, we were teasing a little bit in the beginning of the show that this is a really great time for just anybody to look for Mercury in the sky. And I was wondering if you could speak a little bit towards that, toward our chances. We probably don't want to be doing what our feed partner here is doing and look at it in the middle of the daytime. That might be a little hard. That we recommend that for professionals only. But how about ways that anybody could really image
Yeah,
Mercury?
this is the time that anybody can find Mercury. Now, it has a reputation as being elusive. Even the great Copernicus, who popularized heliocentrism, that the sun is the center and the planets go around it. Even he said he'd never seen Mercury. Of course, from Poland, where he lived, that's in Northern Europe, and Mercury is always much lower than it is here. But you can. We all can this weekend. Now, starting tomorrow night, starting Friday night, and then Saturday, Sunday, Monday. You really have 4 excellent chances, and then it continues after that. But the next 4 nights are really easy. So you know you're going to have clear weather one of those. And here's how you do it. You wait till 40 or 45 minutes after sunset. Your sunset time may be different from mine, depending upon how close you are to the time zone line. So just look up the time of sunset, or perhaps you already know it. Add 40 minutes to it, let's say. And then look in the direction of the west, the direction of the sunset, and boom, you'll see Venus. Can't miss that. It's a zillion times brighter than anything else in the sky. Venus is just dazzling. So you'll see Venus. Now below Venus, far below Venus, you'll find Mercury. There are actually only 2 stars there. The orange star Aldebaran, the brightest star of Taurus, on the left, and then Mercury on the right, about 3 times brighter than Aldebaran. As the nights go on, Saturday night, Mercury will be a little higher up. Sunday night, now it'll be directly to the right of Aldebaran instead of to the right and a little lower than it. Monday evening, the same thing, to the right of Aldebaran. So again, you look for Venus. You need a unobstructed view towards sunset, towards the west or slightly to the north of northwest. You don't want trees or houses or hills to hide that view. You want to look down, not super low. That's the nice thing. You don't need a totally pure ocean-like unobstructed view, but you do need to not have too many obstructions. So you need to look lowish, 45 minutes after sunset. Keep watching for the next 15, 20 minutes because the sky will get darker. Mercury will even get clearer, although it'll get a little lower during that time. Look way below Venus, and anything you see down below it, especially as twilight deepens, you'll see two orange objects. The one on the right, the brighter of the two, that's Mercury. And I promise you'll see it if you look for it. So best time of year, all of this year of 2015, the best time to see it. So it's a little bit interesting that just when all the attention goes on to the Messenger mission, that's also the easiest opportunity for anyone without any telescopes or binoculars or astronomical knowledge or star charts. You don't need anything. Just find it and share that with us here at SLU.
A really great challenge, and yeah, this is the great time to celebrate the Messenger mission in another way by looking at it through your own, looking at Mercury through your own eyes, and having that comparison to the science mission versus what you yourself can do, and we can all do our part in terms of looking at the universe. And I just wanted to mention that we are getting a couple people that are a little disappointed that they weren't able to see an explosion. Like there was that urge to see the Messenger go. But unfortunately, it's on the other side of the Mercury from our view. We can't even see that. There's no way we could possibly do that. But we we appreciate that you wanted to see that excitement. And what I was thinking we could do is we could maybe make a model with our hands, and we can simulate an explosion for people. Bob, how does that sound to you?
Oh, I don't think they'll go for it. But
they won't go for it.
I don't think so. I think the real thing. Also, see if you get a feeling for Mercury. I know it's not scientific, but in ancient times, each planet had its own kind of reputation, probably based on how it looked. For example, we have the word jovial that comes from the idea that Jupiter was sort of a happy, upbeat place. We have the word Saturnine that conveys like heavy, sluggish, sad, because Saturn is the slowest moving of the naked eye planets. Martial arts, court-martial, well, comes from the Martian color, looking reddish, so people associated with fire or war. And Mercury, so Mercury, we have the word mercurial, changeable. Why? Because it moves so darn fast, and you can see it for yourself the next 4 nights as it rapidly changes its position. It'll be a different height above the northwestern sky each evening at the same time, and see for yourself why it's mercurial, how that speediest of all planets, which whips around the sun in only 88 days compared to our 365 days. You can see it for yourself. No knowledge at all is needed. Our SLU telescopes show you fantastic views of asteroids and galaxies and things you could never see, even if you had a very good backyard telescope. But Mercury this weekend, no. You don't need anybody or anything for it. Find it on your own. It's a lot of fun.
Absolutely great challenge, really, and it speaks towards the amateur astronomer's spirit here. And so as we're sort of winding down to the end of the broadcast here, we have one more exciting segment to go after this one, which is coming up, which is going to be Noam Eisenberg, who's going to be we're going to be hearing the interview that we had with this NASA scientist on the mission, and that's going to be coming up. And after that, we're going to end with sort of a celebratory video of all that Messenger has done. So stick around to the end, and you'll have a lot of exciting things. But as we're wrapping up here, I wanted to talk a little bit about some of the exciting things that are still left on SLU. That there's a lot of things coming up. If you didn't get enough of meteor showers coming with the Lyrids a little while back, we're going to have the Eta Aquarids coming up on May 5th. So we're going to have a meteor shower de Mayo celebration that's going to happen a little bit. And of course, we can't forget that of course in the SLU Clubhouse we're going to have another clip that's coming up very soon in the next week, and that's going to be a lot of fun to see. We also have a really special, of course, show that's going to be coming up that Bob has, of course, teased a little bit throughout the show. That's about a year in advance, where we're going to be going back to Mercury again and seeing the transit across the surface of the sun. We've seen the transit of Venus very recently, and that was a glorious occasion, and we're going to see that coming in again, which is going to be quite the sight to see. But as we sort of transition here to the end of these things. I was wondering if you had any sort of last thoughts about this incredible adventure that this mission was, about Messenger, about Mercury, and looking up in the sky and seeing these things from these incredible perspectives.
Well, it's a mixed feeling. It's happy and sad to see the end of a magnificent and successful voyage like that. And speaking to the experts, we're going to run that in a few seconds, speaking to Duncan about that. And just Mercury, it's so unique. When you consider those two planets that we see in the west after sunset, Venus on top, so brilliant, Mercury below it, you'd think, all right, those are the only planets without moons, the only planets that are inside of our orbit closer to the sun, and they are so distinct. Mercury is brightest now when it's farthest. Venus is brightest when it's closest. Mercury has no air pressure at the surface. Venus has the highest, like a pressure cooker. Mercury has the greatest temperature change. It's the darkest planet. It's unique. And so Messenger not only was a fantastic bearer of discoveries, but it also let us pay attention to a planet that's all too neglected, but a fascinating planet that I'm very proud that we covered here on SLU.
Really well said, and yeah, I think that this image here just sums it up. There's so much to be said from the Mercury mission that really speaks towards the diversity of not only experience of the spacecraft itself, but of the variety of just things to discover on this planet. And this mission has really delved very deep into the surface of what there is to talk about with this planet, and I'm sure as we continue onward into the future with more missions, we're going to see a lot more. But yeah, thank you again for joining me on this show, Bob. We're going to move into a great interview segment that we did with NASA scientists at this point. And so here it is, coming up right now.
Dr. Eisenberg, it's so exciting to have you here, and it's quite an honor for us at SLU to be speaking to somebody who is directly involved in the Messenger mission. And whoa, we've got a million questions for you. But I just want to start out thanking you for joining us. And
thank you for having me.
The first thing that comes to mind is what is the mood? What are the emotions on this, which will be its final day alive before it smashes into the planet at almost 9,000 miles an hour? Is it do you feel sad or excited? What exactly?
It's really mixed. It's been such an amazing mission. It's been such an amazing ride from proposal to construction to launch to cruise to orbital operations, and extended mission after extended mission, where we keep on chugging and getting new stuff, new discoveries, new insights, and it's been just so much a part of so many people's lives for the last decade plus, that it's a hard thing. It's celebratory because we've done so much, but it's also certainly very sad that it's all coming to an end. It's almost a little bit hard to believe that the data is not going to be coming down every day, and I won't have to be. We already stopped approving command loads and everything like that, but it's going to sort of really hit home tomorrow, or actually, I guess this broadcast is on the day today.
Yes.
So, yeah.
So before we get into some of the discoveries with it, the first thing, of course, is the messenger is going to smash into Mercury, and I know its orbit is elliptical, which means it's got a low point or a high point. And we were debating here at SLU, the closest point in an orbit in Earth would be perigee. The closest point to the sun is perihelion. What is it with Mercury? Para what?
Well, we use periapsis and apoapsis for the most part, although sometimes we bat around the terms periherm and apoherm for Hermes, for the Hermian relationship, but it's usually sort of the more generic periapsis, apoapsis.
Periapsis, okay. And so we know that it's going to crash in because it's losing height. But I wonder how do you really know quite how high it is? You have a radar altimeter on board, or how do you determine exactly the
Um,
height?
Right. Well, the interesting thing about that is that in the last several orbits, we have actually been using our laser altimeter, which we have used throughout the mission to measure the topography of the surface, mostly in the northern hemisphere, because that's where the altimeter gets the best signal. But as we've been doing these last few orbits, we've been using the laser altimeter as the spacecraft altimeter to determine our height off the ground. As well as sort of the general, the telemetry that we've used before, just from communications and how we've oriented the spacecraft in the past. But the laser altimeter does the real in situ job of telling us just how high we are off the surface, and that's been actually really important in these last couple orbits because you might have seen just recently on the website, they published what our latest news is that yesterday we actually had one last burn, as it were, or expulsion of gas, which had not been originally scheduled because our periapsis was for the last couple orbits was actually a little bit lower than we had expected. So in order to push the spacecraft up one last kilometer and enable us to end when we expected to, or instead of one orbit earlier, we actually had one last maneuver, and what informed us of that was essentially this kind of information.
Okay, great. But no, I still have the question. The orbit before it crashes, how high is it? I mean, is it just barely skimming over the topography at that point? Are we talking about feet or meters or a kilometer or what?
We are talking from what I last saw between 600 and I think 1800 meters or so. No, sorry, between 900. Sorry, yeah, between 900 and 1800 feet. So basically between like the 50th floor and top of the antenna of One World Trade Center. So that I'm not sure. That was before our final maneuver, so it might be a little bit higher than that, but right around that area. I mean, not very high off the ground,
All right.
almost dragging our feet.
All right. So that brings up the question to me, and here's where your expertise really comes in. Um, as I understand it, and I'm going back to school here because I don't know the latest that your wonderful mission has garnered the latest data, but as I understood it, Mercury's atmosphere is extremely tenuous. There's almost nothing there, and so why would it degrade and slow down so much? Or is it the sun's nearby presence and gravity that really exerts the torque that really spells doom for Messenger?
Yeah, yeah, it's not the atmosphere. The atmosphere it's basically a loosely bound exosphere. So there's nothing like drag that affects the spacecraft. What is affecting the spacecraft primarily is the solar wind. That's kind of what's pushing our orbit into sort of every time plus the highly elliptical shape of the orbit that forces or gently pushes the closest approach lower and lower. That's what we with all these final burns have been pushing against in these
I
last
see.
couple
That's
days.
wonderful. I wish Eugene Parker were around. I remember in the 1950s. Well, I don't remember. I was a little kid then. How he people were laughing at him at first when he proposed that there's a solar wind, charged particles from the sun, and if he could be around now to see the actual dramatic effect of them as it destroys a spacecraft, because what I'm getting from you, Noam, is if it weren't for the solar wind, we could keep orbiting probably for years, right?
It would certainly be a lot longer lived. Although on the other hand, the solar wind is one of the things that enabled us to last as long as we have, because you might have known from previous press releases and stuff that the Messenger mission has put out. While we were in our cruise coming into the inner solar system, we used our little stubby solar panels to actually sail the solar wind and provide a little bit of delta V, a little bit of change of velocity on the way in, instead of using some fuel. And that saved us enough fuel to actually enable some of our later extended operations. So it's a blessing and doom at the same time. So.
Hi, everyone. I just wanted to give you a quick update coming in here that actually we've received information that there's been some tweets from Doug Ellison and Mike Siebert that state that they are no longer receiving trajectory information from Messenger. This is not an official report that says that it's crashed, but it's a very positive sign, as much as a crash can be positive, towards the possibility that, yes, Messenger has met its end on this orbit. So all signs pointing toward, yes, that the end of the mission came around as planned. And yeah, thank you for joining us for this incredible sort of event that has happened in our solar system today. And sort of in celebration of that, I have a great sort of celebratory video to lead us out of this broadcast, and to keep in mind all that Messenger has done for us and all that the science really continues to do. So thank you again for watching us, and we hope that you'll stick around on another broadcast. This has been Eric and Bob for SLU. coming up, and you can see like the reds are the regions that are higher up, while the blues are the regions that are lower down. That's what those colors emphasize. This is a false color image, not actually what Mercury looks like. But wouldn't that be amazing if it did? Yeah, so this is where it's expected to crash. And like Bob was mentioning, this is going to be on the other side of the planet than is facing us. So there's no really way that we can see the actual impact, even if we had telescopes strong enough to do that. But what we do have today is some absolutely amazing live images. I didn't even know this was possible before we started investigating this show. But we have images of Mercury from Arizona, USA. Right now, it's just about noon. So this is midday. And so this planet is close to the sun, and yet we're seeing from our feed partner image of Mercury right as it is midday here. Here's it coming in live. And so you see, so this is the planet there. This is planet Mercury at noon from Arizona.
And this is so cool. Of course, this is what we do here at SLU. SLU brings live images, no matter what it is, comet, asteroid, any event at all. Next year, Mercury is going to pass directly in front of the sun, a transit, next May 9th, and we'll bring that too, live as it's happening. But yeah, look at that. And I like this because this really conveys the broiling hot nature of Mercury. It's so close to the sun, it orbits less than half the distance around the sun than we do. And so it's never far from the sun. That's one reason why its daytime facing side gets so incredibly hot. And you can sense it. Look at that. The air is shimmering. We're looking into a blue sky here. The image is not presented in blue, but we're looking very close to the sun in order to see it. There it is, Mercury live.
And yeah, I cannot emphasize how incredible it is to be able to see this in the daytime sky. The best times for observing Mercury tend to be around dawn or dusk, when it's very close to the horizon, which is also tough in itself. But yeah, and actually further on in this broadcast, we're going to talk to amateur astronomers, anybody who's really interested in seeing Mercury. This is a really optimal time, and we're going to get some advice from Bob about that coming up in a later segment on this show. But yeah, there's a lot to talk about, so much, and. Just a question to you, Bob. Is there anything in particular that really strikes your heart in terms of this messenger mission that you're looking forward to discovering today?
Oh, there's so much to talk about because Mercury is a fascinating and unique planet, different from any other. And by coincidence, and this is what the media is pretty much ignoring, right now and through this weekend and right through Monday is the very best time of this year, of 2015, to see it. And you don't have to be an amateur astronomer. Anyone can find Mercury, and we'll tell you how. Easily, it's as bright as the brightest stars, really. So just by chance, Messenger is in the headlines and in the spotlight, and it's going to disintegrate 9,000 miles an hour just when it's most easy to see Mercury from your backyard. So we'll talk about that too. There's so much. This is a very exciting show for me.
Really, I'm in the same boat as you, Bob. And it just speaking to just Messenger's legacy, the spacecraft was launched in 2004, and now it's finally ending its mission. But it only got to Mercury in 2011. It took a very long journey. And just in a short while, coming up in this next segment, we're going to be speaking to Dr. Duncan Kopp, who's going to speak a little bit about the legacy of missions to Mercury, and that's going to be a really fun show, a really fun segment. But right before that, we're going to take a really short break, but we'll be right back in 30 seconds with more of Messenger, more of Mercury, more of this legacy, and more of the impending end. So stick around. We'll be right back. Hi, welcome back to the SLU live broadcast of the Messenger mission end. As it ends its time visiting Mercury. So right now we're going to have a great segment with a film director and documentarian, Duncan Kopp, who, as well as having a PhD in astronomy, has done a lot in terms of astronomy media. One of them, a great documentary being In the Shadow of the Moon on the Apollo mission and the Apollo astronauts. And it's going to be really great to talk to him today. I believe he's just come in with us. Hello, Duncan. Are you there with us?
Hi, yes, I'm here. Yes, live from London.
Oh, it's so great to hear from you again. It's always... Hello and welcome to SLU's latest live show. This is our broadcast on the Messenger mission as it comes to its rather dramatic end. I'm Eric Edelman, broadcasting to you live from Smoky Hollow Studios in SLU HQ in Washington Depot, Connecticut. And boy, do we have a jam-packed show for you here tonight. Absolutely, a lot of stuff to be talking about. So we're going to be going over this messenger mission, what it's been doing, and why it's ending now. What's happening here? Why does it need to crash onto Mercury? What's going on with all that? And to help us with that, we're going to have a lot of experts coming on the show. One of them being our wonderful slew astronomer Bob Berman, and also a lot of special guests. One of them being Dr. Duncan Kopp, who has an interesting tie to the legacy of the Mercury missions, which we'll be hearing a little bit about today. And of course, we're going to be having a showing of our interview that we had just yesterday with a NASA instrument scientist related to the messenger program, Dr. Noam Eisenberg. And that's going to be great. And if that wasn't enough, we're also going to be talking about the top 10 interesting scientific discoveries that have come out of this mission. And this is all going to be accompanied by live images of Mercury from the ground. We have our partner in Arizona that's showing us Mercury in midday, as well as a lot of incredible imagery and video that has come out of the messenger mission itself of Mercury. So do stick around with us. This is going to be an amazing show. And of course, do feel free to interact with us on Twitter. We are going to be listening into the hashtag #SlewMessenger, a little bit of a long one, but if you have questions for us, we might be able to answer them on air, because this is a show for you about this mission, and we'd love to talk about what you're interested in. So thanks again for joining us, and welcome as well to our slew astronomer, Bob Berman, author of Zoom, The Way Things Move. It's great to have you on here, Bob. Thank you for joining me.
Thank you, Eric. Always a pleasure.
It's really going to be great tonight. There's a lot to talk about, and one thing that I'd like to make note of is that we're expecting this spacecraft to end its journey at 3:30 Eastern, 12:30 Pacific, 1930 UTC. This is the estimated time here, but it's going to be interesting to see if that actually happens through this day. Could you maybe speak a little bit, Bob, towards sort of the uncertainties and sort of the drama that's going to be happening today with the end of this mission?
Oh, there's so much to do with it. I mean, the people are heartbroken. They're excited, but heartbroken. The people who have been involved with this, in some cases, for 15 years, many years in space, 4 years orbiting Mercury. And now, if they had their druthers, it would remain, because it's working and it's sending back information with every orbit. Unfortunately, the solar wind, disembodied atom fragments, are creating drag, and they've run out of fuel. It's just plain and simple. And if the orbit were circular, it would be one story, but the orbit is very highly eccentric. I think we have even a video of that to show everybody how close it gets to Mercury and then swings away. Look at this. You see how it gets very close and farthest away? We were discussing this yesterday with one of the messenger scientists. What do you call the closest approach? You know, when an object's closest to Earth, we say it's at perigee. The moon is at perigee, that's monthly near spot. Closest to the sun, it's perihelion. So what's the word for Mercury? Closest spot to Mercury? Well, it turns out it's perihermes. Who would have guessed that? Or periapsis, if you're just talking about any orbit. And that's the spot when it's going to crash. So it's calculated that every time around, it loses another few hundred yards, few hundred meters, gets lower and lower because of this pesky solar wind. And the last orbit around, it just barely cleared the surface. So this next time around, coming up in less than an hour and a half now, it's expected that, look, it's going sideways as much as downward. Sideways, and it's going to smash in at almost 9,000 miles an hour. Seatbelts are not going to help with that. Airbags are not going to help. 9,000 miles an hour will smash into some terrain, and that will be the end. And it'll be on the far side of Mercury. We're not going to see it, but the spacecraft, this is so sad, will not reappear. So that'll be the end of it.
It's going to be, there's so much to do here. And yeah, this is actually an image of what the crash site expected for the spacecraft is going to look like here.